Assalamualaikum guys, welcome back. Okay, so now in this lecture 28 we are going to talk about the different types of covalent compounds that we have. We've got simple covalent and we've got giant covalent. Okay, so simple covalent structures पहले उनकी बात कर लेते हैं, and then we are going to talk about the giant covalent structures. So now simple molecular structures or simple covalent structures are basically the ones which are simpler in structure. They're the simpler ones include all the halogens, all the halogen acids, all the group all the noble gases, many of the group 6 elements, many of group 5 elements as well. The gases basically are all simple molecular compounds or simple molecular structures. Basically the ones which have lower melting and boiling points are simple molecular, okay, and they are generally they have a simple molecule, they have a very small molecule or a small structure. For instance, they are a molecule made up of only 2 atoms, okay, as in case of most diatomic gases, which are also all simple molecular compounds. Whereas in case of giant covalent structures, you've got a series of thousands of covalent bonds joined to each other, meaning one atom, then second, then third, and fourth, and fifth, and sixth, and so on. Thousands of atoms joined together by a giant series of covalent bonds in them. Okay, and you've already done giant covalent structures in your O levels as well. There are just a few additions in A levels. The first one is diamond, and the second one is graphite, and the third one is silica, SiO2, silicon dioxide. You've done all 3 in your O levels. And these are the ones which you have to do over here as well, but in a bit more detail, okay. And apart from this, you've and giant covalent structures are actually insoluble in both water and organic solvent. You know that from your O levels, and they have very high melting and boiling points. And by the way, in giant covalent structures, the force that has to be overcome in order to melt them or boil them are actually the covalent bonds themselves, not the intermolecular forces. Over here in giant covalent structures is the covalent bonds that you have to melt. It's the covalent bonds that you have to break, okay, in order to melt them. Whereas in simple molecular structures, you've got to break or overcome the intermolecular forces. This is the major difference between both of them, and that major difference between their properties, okay. Simple molecular structures, they have very weak intermolecular forces, due to which they have very low melting and boiling points, as compared to the giant covalent structures, which have a huge series of covalent bonds that need to be broken down in order to melt them down. That's why a diamond is considered as the hardest metal on earth, because hardest solid on earth. The reason is because of the tons of covalent bonds that it has, okay. Now over here, the intermolecular forces are responsible for the physical properties. All group 7 elements, they are soluble in non-polar solvents. By the way, the simple molecular are soluble, whereas the giant covalent, they do not dissolve in non-polar solvent. This is the general structure, and we've already talked about them. The bromine molecule over here has strong covalent bond in between them, but in between the molecules, not between the atoms, but rather between the molecules, we will find the weak intermolecular forces. Within the molecule, meaning the intramolecular, you must know the difference between intramolecular and intermolecular, okay. Intramolecular means within the molecule, intermolecular means between the molecules, okay. Inter means between, and intra means inside the molecule, okay. These are the 2 terminologies that are commonly asked or commonly tested on the past papers as well. The intramolecular are the strong covalent bonds that they have. They are strong, but it's not the covalent bonds that are broken while melting down or boiling them. Rather, it's the intermolecular forces, and the intermolecular forces most common in halogens or these groups are actually the van der Waals forces. Unless you are talking about the halogenic acids, in which you might find both permanent dipoles and hydrogen bonds as well. But over there, you will find the van der Waals forces to be very dominating, okay, and do not conduct electricity. Whereas over here in graphite, being an exception, conducts electricity, and the reason is because of the delocalized 4th electron that it has. You must have studied about that in your O levels. Well, in the next lecture, we'll be talking in detail about the giant covalent structures, all of them one by one. So inshallah, it will get clarified further in the next lecture, and that's it for this lecture. Thank you.